Hello, dear students. In last classes, we were studying about the elementary mathematics. In fact, I launched a course on elementary mathematics for class 11th ISC physics. So now, today we will study about elementary concepts of differentiation, as differentiation has application in your physics. So we will today study about the elementary concepts of differentiation. So now students, suppose if we write down a function relating two variables x and y, suppose that I am writing function y is equal to 5x plus 3. This is a function. It is relating two variables. Y is what? Y is a dependent variable and x is what? X is an independent variable, students. Now, here students, put x is equal to 1. Put x is equal to 1. So in this function, if you will put x is equal to 1, then here you will get y is equal to 8. Put x is equal to 2, then here you will get y is equal to 13. Put x is equal to 3, then here you will get 18. Put x is equal to 4, then here you will get y is equal to 23. So now, what does this signify here? Here, if we are changing the values of x, here if we are changing x, then what is happening? Y is also changing. Y is also changing. For x is equal to 1, y is 8. For x is equal to 2, y is 13. Is this clear? And so on. But uh, here we are changing x and y is also changing, and this change will depend upon the nature of function. This change will depend upon the nature of function. Sorry. The change in dependent variable, I will denote it by delta y. Here delta y is what does it represent? It represents change in dependent variable. The change in independent variable, I will denote it by delta x. Now students, the ratio of change in dependent variable, that is delta y, to the change in independent variable, that is delta x, this is what? Delta y upon delta x. It is what? The ratio of change in dependent variable with respect to change in independent variable. And students, it depends on which? It depends on nature of function. It depends on nature of function. Now, next. Now, students, this delta y upon delta x, that is ratio of change in dependent variable with respect to change in independent variable. Now, students, it may be constant for some functions and it may depend on one or both variables for some functions. For some functions. Now, let me give you one example. Suppose Do you know the straight line equation, that is linear equation? Y is equal to mx plus c. Here students, the ratio of change in dependent variable, the ratio of change in dependent variable, that is delta y, with respect to change in independent variable is what? Constant m. Let me clarify this. Suppose you have y is equal to, suppose you have y is equal to 2x plus 3. It is a linear function. It is a linear function. Now, the ratio of change in dependent variable with respect to change in independent variable, here it will come out to be 2. See how? Put x is equal to 1. So, what we will get? Y is equal to 2 plus 3, 5. Next, put x is equal to 2. What we will get here? Y is equal to 7. Put x is equal to 3. What we will get here? Y is equal to 9. So just see, change 5 to 7, changes 2. 7 to 9, changes again 2. Similarly, if you will put x is equal to 4, you will get y is equal to 11. So here change is again 2. So now students, your change in dependent variable is how much? 2 with respect to change in independent variable. So here change in 2. So that's why here I have written delta y upon delta x. That is change in dependent variable with respect to change in independent variable, and it is coming out to be 2. Here we are changing independent variable, x is equal to 1, x is equal to 2, x is equal to 3. Corresponding change in dependent variable is coming out. Y is equal to 5, 7, 9. How much is change? 5 to 7, 2. 7 to 9, 2. 9 to 11, 2. So here delta y upon delta x is equal to 2. This is the concept of ratio of change in dependent variable with respect to change in independent variable. Now next. Now students, suppose you have y is equal to x square. Y is equal to x square. Now students, here the ratio of change in dependent variable with respect to change in independent variable, it will depend on the value of x. As x will increase, y will also increase, and it is a non-linear function. Non-linear function. Non-linear function. That's it. So now next. Now students, when the change done in x, that is delta x, and when it is very small, when it is very small, in mathematical form, if I will write the change delta x to be very small, I will just put here delta x tends to 0. It means the change in x is very small. Then students, delta y, it is written as dy, and the ratio delta y upon delta x, limit delta x tends to 0, delta y upon delta x, it will become equal to dy upon dx. Here you can just simply understand this: limit delta x tends to 0, means delta x, the change in x is very small, and here we have applied limit that delta x tends to 0 means change in x is very small. So limit delta x tends to 0, delta y upon delta x, it is equal to dy upon dx, and students, this dy upon dx, it is called the differentiation. It is called the differentiation. It is called the differentiation of y, differentiation of y with respect to x. Means change of y with respect to x, or the differential coefficient of y with relating to x. So students, what does dy upon dx represent? It represents the rate of change of y. It represents the rate of change of y, of y with respect to x. This. So this is the physical significance of differentiation, rate of change of y with respect to x. And students, next we will see geometrical significance of dy upon dx. For that, let me upload one diagram. See this. Now students, geometrically, we will talk about the significance of dy upon dx. So here, student, dy upon dx, it denotes the slope of the curve uh, between variables x and y according to the given function at the point xy, and we can write dy upon dx, dy upon dx is equal to tan theta. Tan, this you will study in detail in your mathematics course also. I am just giving you an overview of elementary mathematics, which you will use in 11th and 12th in physics. Next, students, we will see differential coefficients of some simple functions. So let me upload that. See, function y is equal to fx. If we have y is equal to x to the power n, then differential coefficient dy upon dx, it will be nx to the power n minus. Next, if we have y is equal to constant, then dy upon dx will be 0. If we have y is equal to log base ex, dy upon dx is equal to 1 upon x. If we have y is equal to log base ax, we have dy upon dx is equal to 1 upon x log base ae, which is equal to 1 upon x log base ea. This I have, I think, taught. If not taught, this is the, this way we can change the base. If we have y is equal to sin x, dy upon dx is equal to cos x. If we have y is equal to cos x, then dy upon dx is equal to minus sin x. And if we have y is equal to tan x, then dy upon dx is equal to sec square x. And if we have y is equal to x, then we have dy upon dx is equal to 1. So these functions you have to remember the differential coefficient of these functions. Now next students, we will see differential coefficient of product of two functions. Next is differential 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 coefficient of product of two functions. Product of two functions. Product of two functions. Now, if let y is equal to f1x in dot f2x. Here y is equal to product of two function, that is f1x and f2x. Now students, if we have to find differential coefficient, that is dy upon dx, then how to find? Just see, dy upon dx is equal to first function into d upon dx of second function plus second function into d upon dx of first function next. If we have to write in terms of f1x and f2x, then dy upon dx, first function was what? f1x into d upon dx of f2x plus f2x, second function is f2x into d upon dx of f1x. So this you have to remember. This is the formula for differential coefficient of two functions. We will see one example. Suppose we have y is equal to x square sine x. Then how to find its differential coefficient? D upon dx of x square sine x is equal to, first function is what? Here I am taking x square and sine x as second function. So here f1x is x square, f2x is sine x. So the rule was f1x means x square into d upon dx of f2x sine x plus f2x means sine x into d upon dx of x square. So just see. So now here it will become x square. D by dx of sine x, it is what? How much? D upon dx of sine x. Just see. Cos x. It is cos x. X square into cos x plus sine x. Now students, it is x square. Here we will use this formula. Y is equal to is what? X square. So just compare from here. Y is equal to x to the power n. Here n is 2. So, and what was its differential coefficient? Dy upon dx is equal to nx to the power n minus 1. So here dy upon dx, it will become 2 n is 2 into x to the power 2 minus 1. So here it will become 2x. So here sin x into 2x. So if you will write it in concise form, x square cos x plus 2x into sin x. So this is the differential coefficient of product of two functions if y is equal to x square sin x. Now students, next we will see differential coefficient of quotient of two functions. Differential coefficient of differential coefficient of coefficient coefficient of quotient of quotient of two functions of two. Suppose you have y is equal to f1x upon f2x. We have function y is equal to in the form of numerator and denominator. So here and I am denoting numerator by n r and denominator by dr. Now students, we will find its differential coefficient, that is dy upon dx. So just see how to find. So here dy upon dx, it will be equal to denominator into derivative of numerator, means dy upon d upon dx of numerator minus numerator into d upon dx of denominator upon denominator का square. So this is the rule to find the differential coefficient of quotient of two functions when it is given in the form of numerator and denominator. Let us solve one example. Suppose, let me give one example. Suppose we have y is equal to sin x upon x square. So now, here we have to find its dy upon dx. Just see how to find. I'm solving here. So we have to find its dy upon dx. So dy upon dx is equal to denominator into x square into d by dx of numerator. D by dx of numerator. So here numerator is what? Sin x minus numerator. Numerator is what? X square. D by dx of denominator. Denominator is what? Denominator is x square upon denominator square. So denominator is what? X square whole square. So now students, here dy upon dx, it will become x square into d by dx of sin x, it will be cos x minus x square, and d by dx of x square, we have solved this earlier. So it is 2x upon x to the power 4. So this is the dy upon dx of sin x upon x square. And students, Here, sorry, here it will be bit. Here it is what? Minus numerator into d by dx of denominator. So here it will be sin x. Here in place of x square, it will be sin x minus sin x. Here also will be sin x will be sin x and into. Now next. So now students, here take x common. So here dy upon dx, it will become what? Take x common in numerator and denominator. So here it will become x cos x minus 2 sin x, 2 sin x upon, it will be x cube. So this is differential coefficient of sin x upon x square. So in this way you have to solve. So don't be confused in numerator and denominator. This is the rule to find out. Now, so this was all about the differential coefficient of quotient of two functions. Now students, next we will study about the application of differentiation in physics. So next for a few minutes we will discuss about that. Next is application in physics. Application in physics. Application in physics. Now students, in physics we study the variation of one variable with respect to another variable, and in such case the use of differentiation is very useful. For example, rate of change of displacement with respect to time t, that is, if we have ds upon dt. ds upon dt is what? Rate of change of displacement with respect to time t, and it will give the velocity. It will give the velocity. This is first. Next, students. Next is, you have studied, I think, about acceleration in 9th, 10th. Rate of change of velocity with respect to time t is what? Acceleration. So if rate change in velocity is dv and change in time is dt, so dv upon dt will give the acceleration. That is rate of change of velocity with respect to time t. Now students, next is rate of fall of temperature theta with respect to time t. That is d theta upon dt. D theta upon dt is what? Rate of fall of temperature with respect to time t. So here it is fall. So I am here putting minus sign. That is minus d theta upon dt. It will give the rate of cooling. It will give the rate of cooling. So, so now, and next students, while studying the variation of one variable, say y, uh, with respect to other variable, suppose that it is x. So the nature of variation is determined as follow. We will see about the nature of variation. Suppose students, if we have, we will discuss one by one. If we have dy upon dx and dy upon dx, and it is coming out to be greater than 0. It is coming out to be greater than 0. that is, it is positive. Uh, then students, what is the significance of this? Y changes in the same way h x will change. Suppose if x is increased, then y also increases, and if x is decreased, y also decreases. You can verify this any by taking any example. Suppose take y is equal to 5x plus 3. Increase x, y will also increase. Decrease x, y will also here decrease. So this is all about the significance of dy upon dx greater than 0. Next, b. Next is dy upon dx less than 0, means negative. Then students, in this case, y changes in opposite way as done in x. For example, if x is increased, then y will decrease. And if x is decreased, then y will increase. So this is the significance of dy upon dx less than 0. So here it is. You can just see y is equal to, take this example, y is equal to minus x. Increase x 1, 2, 3, then what will happen? Y will come up to be minus 1, minus 2, minus 3. So y is decreasing as x is increased. Is this clear? And decrease x here, minus 1, minus 0.5, then what will happen? Y will increase. You can verify this from exam. Next is C. When dy upon dx, when y is equal to constant, when y is equal to constant, then what will happen? D, what will happen? Y will not change with x. In other words, y is independent. In other words, y is independent of x. And in this case, dy upon dx, it will come out to be 0. These are the application in physics. And students, next we will study about kinematics uh, in class 11th. And also differentiation has significance in kinematics. Suppose students, when your displacement or distance s is expressed in terms of time. Suppose s is equal to function of t. Then students, we can determine velocity from this. How? Velocity is equal to rate of change of displacement with respect to time. So here v will be equal to ds upon dt. And students, here we have obtained velocity, and this obtained velocity is called instantaneous velocity. Instantaneous velocity. Instantaneous velocity. That is velocity at particular instant t. So this is instantaneous velocity. We will study about this in detail in kinematics. And now students, we will talk about the graph of s and t and slope of tangent drawn at any point. So let me upload the graph. This is the graph between s and t, and velocity at a point is given by the slope of the tangent drawn at that point. And here, if we will talk about this point, then here students, v is equal to tan theta. which is equal to ds upon dt. ds upon dt. Just like same that we have determined the slope of what, which curve, slope of curve between variables x and y. Their dy upon dx was equal to tan theta. So here v is equal to tan theta is equal to ds upon dt. You can compare from that. Now next, students, we will talk about when the velocity expressed in terms of time t. So here next, when velocity expressed in terms of time t. Suppose velocity is equal to function of time. Then students, we can calculate acceleration. Acceleration is what? Rate of change of velocity. So A will be equal to dv upon dt. And this acceleration is called instantaneous acceleration. Instantaneous acceleration. Instantaneous acceleration. That is that is acceleration at a particular instant t. We will talk about the graph between time and velocity next. Let me upload that. Now see. Now students, here this is the graph between time and velocity, and slope of tangent at a point gives the instantaneous acceleration at that point. Suppose consider this point, and here A will be equal to tan theta, which is equal to dv upon dt, rate of change of velocity with respect to time t. This is about the instantaneous acceleration. Now friends, next is last one is what? We will see about last one. Last one. Now friends, in terms of differential coefficient, the acceleration is also given by a is equal to dv upon dt. Here multiply and divide by ds. So here if you will multiply and divide ds upon dt into dv upon ds, and students, here a will be equal to v into dv upon ds. So uh, you will come to know the way your course will go forward. So you will get to know about this. So students, this was all about the differentiation, and that is elementary concept of differentiation, and we studied about application in physics. So if you have liked my video, then you can like, share, and subscribe my YouTube channel. That's all. Thank you.